Hello everyone, for today's video, I'll be focusing on everything you need to know about graph plotting in the GDC. First of all, let me go into the graph and let me show you the interface. This box up here is where I type in the equation of the function. Let's say I want to type the graph of y equals to x squared. I can come up here and just type x squared and press enter. If I want to edit the equation of the function, I can double click on this function. So let's say I meant to type in x squared minus 2. I can do that and it edits the function for me. Now let me insert a new page by pressing doc, insert, and then graphs. Let's see how to plot some very typical functions. First off, for trigonometric functions, let's say sine x, we come to the trig button over here on the left, press sine, and then put x, and then press enter. Now how about sine square x? The GDC doesn't understand sine square x, so we must do sine x, whole thing, and then square. And there we go, we have the graph of y equals to sine square x. Now, let's say they ask you to plot x sine x. If we come here and just write x sine x, you can see that the sign is italicized, and if we press enter, this does not work. So let's come back here and edit my function. What is wrong? When I'm multiplying two functions together, I make it a good habit to type in the multiplication symbol. Now then it's correct. I can press enter and it gives me the correct function. How about e to the power x? What I can do is come to this button over here on the left, press e, and then put my power x. Then I press enter. One note is that the GDC does not recognize if you type in the keyboard e over here. It will treat the e that you type here as a variable, which is wrong. For logs and square roots, the buttons here are all on the left. Press Ctrl and this to key in the square root, and press Ctrl and this to key in functions in terms of log. A note for log, the GDC allows us to plot the log of any base. So we can plot log base 2 of x, and it will give us just that. Now let me introduce you to this button over here on the left. This button is where you type in many of the math symbols you may want. For now, we're just going to look at mod of x. This is what you press to type in the absolute value symbol. So let's say I want to find mod of x minus 2. And there we go, we have plotted mod of x minus 2. Before we move on to analyzing graphs, I'm going to show you how to plot a function for a specific domain. So let's say I have this graph x squared minus 2, and I want to plot it for the domain where x is more than or equals to 0. What I can do is come here and use this symbol over here, this little line. What this does is tell the GDC that you're going to type in a domain. So you can come here and press Ctrl, then equals, and press this line over here. And then we can do x. Press Ctrl equals again to get this more than or equals to sign. More than or equals to 0. And press enter. Now we have the graph of x squared minus 2, but restricted to this domain. Moving on to graphical analysis, let's say I have the graph of y equals to x squared minus 2, and I want to find the x-intercepts and y-intercept. Let's say I want to find the y-intercept first. I can use this feature called trace. I go over here to menu, 5, trace, and then press trace all. By default, it will tell us the value of y when x is equals to 0, which is your y-intercept, 0, negative 2. For my x-intercepts, I will go under menu, 6, analyze graph, and then press 0. After you select this, you can select a lower bound and an upper bound, and the GDC will find an x-intercept between these bounds. If there's no intercept between these bounds, the GDC will not give anything. So let's say we want to find the intercept on the left. I'm going to select my lower bound and upper bound as such. And there it gives me the intercept on the left. We can only find the x-intercepts one at a time, so I'm going to go back here and do the same thing. Menu, analyze graph, 0. Select my lower and upper bounds, and here. The GDC tends to overlap the text, which will make it very difficult to see, so what I can do is click and drag this elsewhere, so I can see these two very clearly. The next thing we're going to do is find the local minima and maxima. To find the local minimum, what I'm going to do is go to menu, analyze graph, and then 2, minimum. Again, it will ask for the lower bound and the upper bound, and this will give you the lowest point between your lower and upper bound. I'm going to go to Analyze Graph and 3, Maximum, and then find my maximum point over here. And so, this is how I find both the local minima and the local maxima. Alright, let's say I plot these two graphs, x cubed minus 3x and y equals to sine x. And the question asks us to find the intersection points. To find the intersection points, I come over to the menu, 6, Analyze Graph, and 4, Intersection. Again, I take the lower bound and the upper bound, and it will return us one of these intersection points. This only finds us one intersection point, so if you want to find all the intersection points, we have to repeat this a few more times. Now there's another way to find the intersection points if there are many intersection points. This sneaky little trick is to go to Menu, 8, Geometry, Points and Lines, and Intersection Points. And if you select your graphs, it will return you all the intersection points between the graphs. This is quite useful but may be a bit difficult for some of you to remember. So if you can't remember this, just do Menu, Analyze Graph, and Intersection. It is not that much slower. Now before we cover calculus, let's say I have this graph, 1000 over x minus 2. And I press enter. Wait, where is the graph? There's no graph over here. What we need to change is the window settings. Come over here to the menu and press Window/Zoom, and then Window Settings. Now what this does is change this number, this number, this number, and this number. So you can edit the axes to become longer. So let's say I want my minimum x value to be negative 100 and my maximum x value to also be 100. And then while I'm at it, I'll change the minimum y and maximum y values. And press OK. And there, we can now see the graph very nicely. Now sometimes if you can't see the graph, one thing that you need to remember is to change your window settings. And even if sometimes you can see the graph, let's say you change your window settings to something like this and you only see a portion of the graph, then this is wrong. Now in case if you're really not sure and you're afraid to miss out certain parts of the graph, what you can do is come over here to the menu and then use these two options, zoom in and zoom out. So I can use zoom out, and it will help me zoom out. And here it really confirms that these two segments are the only two segments of the graph. There's nothing else. That's all for changing the zoom and the window settings. The next segment will be all calculus related. If you're not familiar with calculus or have not covered that yet, you can watch my calculus videos first. Calculus is all about finding derivatives and integrals. Let's say I have this graph here, 0.3 e to the power x squared minus 5. To find the gradient at a point, I can come over here to the menu, Analyze Graph, and then click 5, dy over dx. If you want to find the gradient at let's say x equals to 1, I can just type in 1 and press enter. And that gives you the gradient at x equals to 1, which is 1.63. Now something else you can do is plot the graph of the derivative. So what we can do is to go over here to this button, click it, and you see this, d over d. Click this, and we fill in the x, d over dx. And if you want to find the derivative of the first function, we do f1x. And you'll find us the derivative of f1x. Ta-da! You can also find the second derivative, just do the same thing, with d2 over dx squared, and write f1x in the bracket. And that's the second derivative of f1x. This only works up to the second derivative though, it doesn't work for higher order derivatives. And note, the GDC does not understand how to take the derivative of a derivative. So let's say if I want to find d over dx of f2x, this over here, when we key it in and press enter, this does not work. You can see that the pink graph does not appear anywhere in this axis. This is because the GDC does not understand how to plot the derivative of a derivative. We can only find the graphs of your first and second derivative of your original function. Now how about integration? Let's say I want to find the integral from 0 to 2 of this function over here. So what I can do is come to the menu, press Analyze Graph, and press Integral. I'll click on the graph that I want, this blue graph, type in 0 as my lower bound, and 2 as your upper bound. and this will be my integral from 0 to 2. As you can see, this gives me a negative answer. This is not the same as finding the bounded area or area under a curve. If you want to find the area, we need to use a different thing. Go over to your menu, Analyze Graph, and select Bounded Area. Select your graph and the x-axis, and then key in 0 and 2. Now this then gives you the bounded area between these two graphs and not just the integral. Now this also works to find the bounded area between two functions. We come over here to the menu and we want to find the area between, let's say, this point and this point over here. This bounded area between the red and the blue curve would just be 6.43. That's all for this tutorial. I know this was a lot of content that I covered today, but with enough practice, you'll be able to master the GDC. Thanks so much for watching.